Hello, welcome to the 2021 Embedded Vision Summit. My name is Quenton Hall. I'm an AI systems architect with Xilinx, and today I'm going to provide you with a demonstration of adaptive healthcare inference with Crea and Amazon SageMaker. You may be asking, what is Crea? The Crea product family is a new offering from Xilinx. Crea is a production SOM module targeted for a variety of industrial vision and edge inference applications. Crea accelerated applications enable firmware and AI developers with pre-built acceleration and video pipeline infrastructure. The Crea software stack gives users the choice of either Ubuntu or Yocto flows and includes features such as native Python and Vitis AI support. With Crea, development teams can easily deploy their applications without need to develop FPGA expertise. In this demo, we'll show how Crea can be used to deploy AI at the edge for medical imaging applications. Crea, in concert with AWS Greengrass IoT and SageMaker, provides a complete edge-to-cloud deployment solution. In this use case, ML predictions can be made securely at the edge, ensuring patient privacy, while also enabling remote clinicians to provide a diagnosis and analyze the results of the machine learning model predictions. ML models can be updated in the cloud and then redeployed via over-the-air updates to the edge device. This enables the management and update of a large network of similar edge devices. Now the moment you've been waiting for, let's check out the demo. First, I'm going to access via remote desktop a Linux machine that is running an embedded web server. This embedded web server provisions connectivity to AWS in order to facilitate remote management and inference on the edge device. So in this context, we can upload a variety of X-ray images and make a prediction on the Crea SOM as to whether these images are of patients who have COVID, pneumonia, or are normal. Let's upload an image now. From the local machine, I can select any one of a variety of different test images. The uploaded image is now stored in AWS in an S3 bucket. Now what we would like to do is to pass this particular image down to the Crea SOM to run inference. In this case, the SOM is located in Bangalore, India. In this case, you can see that the image is predicted as normal and that it has taken approximately 11 microseconds to run inference on the SOM. Thus, the delays that you saw through this process were actually the result of network routing delays, while the SOM is very capable of processing hundreds of images per second in order to effect these predictions. In this context, the predictions from multiple clinicians or multiple clinics could be affected on a single edge device, or you could have one edge device per facility and have a regional radiologist who would access the predictions remotely. Notice that as we continue to run inference, we see different predictions for different images. In this case, this is a COVID image, which is actually to some degree visible to the human eye. Now let's take a look at the heat map. The heat map provides the clinician with a sense of the specific features in the image that the neural network is basing its prediction on. This helps to provide guidance to the clinician as to why the neural network has predicted a specific scenario, in this case, COVID. We mentioned previously that we were using a remote Crea SOM in Bangalore, India, but we could also have a locally connected Crea SOM acting as an AI box. This would be the typical scenario that we would see in a clinic or a hospital. Now, let's take a look at the management interface. We mentioned that we could potentially have a plurality of many different Crea SOMs located in different clinics. In this context, being able to manage the storage of images and configure devices gives us the power to administer the system remotely. Through the course of today's demonstration and presentation, we have illustrated for you how it is possible to use the Xilinx Crea SOM in an edge-to-cloud configuration. The Crea can support analytics as an on-premises AI box, but could also propagate those predictions to a remote clinician who could examine them and consider them further in order to make a patient diagnosis. Furthermore, the performance of the Creasom is sufficient in order to support not just a single local X-ray machine, but could be provisioned to support multiple on-site X-ray machines as well as regional satellite clinics that may not have access to such infrastructure. I hope that you've enjoyed the demonstration today, and now I'll open things up for questions. Thank you.